everyone, welcome to all in this video lecture series of Database Management System. I am Deepak Aneja, Assistant Professor, ABES Engineering College, Ghaziabad. In this video, I will cover the important topic of functional dependency from the Unit 3, Database Design and Normalization. These are the content of today's video. In this video, I will cover introduction to functional dependency and how we'll calculate the the functional dependency in the table is valid or not valid or invalid. Then types of functional dependency, and then Armstrong axiom in functional dependency. So let us start with the topic functional dependency. A good relation or design is the one which has the minimum redundancy and minimum data dependency among the attributes of the relation. Functional dependency is the one of the core concept in the relational database design. It helps to maintain the quality data in the database. Then we have to understand what is this functional dependency. A functional dependency is the relationship between any two attributes of a relation table. For example, there is a relation R, X and Y are the attribute of the relation R. So in this example, X determines Y. So we can say that Y attribute is functionally dependent on X. So X is the determinant attribute and Y is the dependent attribute. So to check that given table, given relation is valid or not, we have to check the tuple 1 X equals to tuple 2 Y. Then we need to check tuple 1 Y must be equals to tuple 2 Y, where T1 and T2 are the two tuples of the relation. X and Y can be a single attribute or set of attribute. So left-hand side of the above functional dependency is called determinant and right-hand side is called dependent attribute. Let us take a simple example. There is a relation student. There are two attributes, student ID and student name. If we can say that student ID determines student name, there are four cases. Suppose there is roll number 1, student name is X. There is roll number 2, student name is Y. There is no problem in this case. This is valid. This is valid. Student name is dependent on student ID. So X and Y both are the different student and their roll number are different. There is next cases. There is student ID, student name. Suppose there is roll number 1, name is X, roll number 2, name is X. This is also valid case. These two are the different student because student name determines through the student ID. So student ID are different for the same name student. There is one more scenario, student ID, student name. If there is roll number 1, name is X. Again, there is roll number 1 and name is X. This is also a valid entry because both the entries are the same. This second entry is the duplicate entry. This is the duplicate entry, but no issue in this entry. So this is also valid case. There is one more scenario, student ID, student name. roll number 1, student name is X. Roll number 1, student name is Y. Student name is dependent on student ID. Both are different name, different student, but student ID is 1. This is impossible. So this entry is invalid. So we need to check this functional dependency X determines Y or SID determines S name from the table, or from the tuples. So let us take one more example. This is a student table. There is student ID, student name, student phone, student state, student country, and student age. Now question is check whether the given functional dependencies are valid or not. We have to check these given functional dependencies are valid or not from the table or from the tuples given in this table. Now first, student ID determines student name. Student name is the dependent attribute that is determined through student ID. Now formula to check if tuple 1 X is our student ID and student name is Y. That is equals to tuple 2 X. Then we need to check tuple 1 Y must be equals to tuple 2 Y. Now check. Here is student ID 1 that determines student name. Then roll number 1, student ID 1. There is no other entry for this student ID 1. Same case is with 2, student ID 2. Same with student ID 3. Same with student ID 4 and student ID 5. There is no such case exist in the table. So this is the valid functional dependency. Now take the second functional dependency, student ID determine student phone number. All the student ID entries are different. So this is the valid entry. Same case with student ID, student state. This is also a valid entry. Same case is SID determines student age. This is also a valid entry because all the student IDs are different entries. Now check for student name and student state. This is Y and this is X. Student name is A. There is one more student name A. So tuple 1 X equals to tuple 2 Y. Then we need to check the student state. Student state of both the student must be same, but this is different. For student name A, first the state is UP, and for second student with the same name A is Haryana, HR. So this functional dependency is invalid. No need to check for other student names. If there is one invalid entry exists, then we can say that the given functional dependency is invalid. Now let us take one more example. There is student table, fields are, attributes are student ID, student name, marks, department, course. Now we have to check the given functional dependencies are valid or not. Student ID, student name. Student ID, here we can see student IDs all are different. So this is the valid entry. We can say that no need to check for the same. This is valid entry. Now second is student name determines student ID. The student name determines this is X, this is Y. Now student ID is dependent on student name. So there is student name is A, another is here student name A. So both the entry must be same. The formula is tuple 1 if tuple 1 X equals to tuple 2 X, then tuple 1 Y must be equals to tuple 2 Y. But this is not same. This is not equals. So this is invalid, or we can say not valid functional dependency. Now check for student ID. Marks student IDs are different. So we can say this is the valid functional dependency. Now check for department course. Department course. Department is CSC. Now check for CSC. There is C1 and C2. So this is invalid entry. So this functional dependency is invalid. Now check for marks determines department. Marks determines department. There is 68 marks and same here is 68 marks. Both the department are same. So this is valid. Now check for next entry. There is 60 and there is one more entry for this 60 marks. Department is EC and department is EC. So this is also valid. Now check for one more entry, 70, 70. Here is IT and triple E. So this is invalid entry. So we can say that this given functional dependency is invalid in this case for both the marks are 70, but department are different. Now check for student ID name. This is the composite attribute student ID and student name both. Now, there is no same entry exist because student ID are different, are unique. So this is also a valid entry. Now check for name marks and department name and marks. A68. There is A68 and there is one more entry for this A68. We need to check department. Department is CSC, CSC. This is valid. B60 and here is B60. So this is also valid entry. Now check for C70 or this is D70. Both are different entries. Compositely, both are different entries. So we can say that this is valid functional dependency. Next, check for name marks determines department course. So here is A68. Here is also composite department and course CSC C1. For the same entry A68, here is CSC C2. Both are different. Both values are different. So we can say that this is invalid functional dependency. I hope you can understand this concept. Now move on to types of functional dependency. So functional dependencies can be classified into four types. First one is trivial functional dependency, non-trivial functional dependency, transitive functional dependency, and multi-valued functional dependency. So in this video, we will cover first two functional dependencies, trivial functional dependency and non-trivial functional dependency. In the last two, we will cover these in the upcoming videos during the topic normalization. During the normalization, we will cover these functional dependency. Now, what is trivial functional dependency? If functional dependency is trivial, if and only if a dependent is always a subset of determinant. If if X determines Y, then Y is the subset of X. Or if we take intersection of X intersection Y, that does not equals to phi. That does not equals to phi. There is some common value for that is called trivial functional dependency. For example, in this table, the student ID and student name determines name. Here student name, sorry, here is student name. The common is here, the common intersection is student name. So we can say that this is trivial functional dependency. Or there is one more, student ID determines student ID. So if we take intersection of both, that is student ID. So this is called trivial functional dependency, or trivial functional dependency is always valid. No need to check. Trivial functional dependency is always valid. So there is no need to check trivial functional dependency. Next, move on to non-trivial functional dependency. So a functional dependency is a non-trivial if and only if a dependent is not a subset of the determinant. If X determines Y, then Y is not the subset of X. So we can say that X left hand side intersection Y, that is equals to 5, that is empty. There is no common attribute between left hand side and right hand side. That is called non-trivial functional dependency. For example, in this table, student ID, student name, marks. Here, student ID determines student name. So if we take intersection of left hand side and right hand side, that is equals to 5. That is no common attribute between these attributes. So this is called non-trivial functional dependency. Same case is with student ID determines marks. There is no common attribute. So this functional dependency or such functional dependency is called non-trivial functional dependency. Non-trivial functional dependency may be valid or invalid. So we need to check through the table. We need to check through the table. Next is Armstrong axiom or properties of functional dependencies. So basically, there are two different set of rules. First one is primary rule and second is secondary rules. First one, primary rules are reflexivity. What it says if X is a set of attributes and Y is the subset of X, if X determines Y and Y is the subset of X, this is same as of trivial functional dependency. So then X holds Y, and this property is trivial property, or trivial property is always valid. This is through the rule of reflexivity. This is through the rules of reflexivity. Second is augmentation. Augmentation says if X determines Y, holds, and Z is the attribute set. So XZ determines YZ. So this attribute is associated with left hand side and right hand side both. So XZ determines YZ also holds. So this is also valid. Now, through the rule of transitivity, it says if X determines Y holds and Y determines Z holds, then we can say that X determines Z also holds. So if X determines Y is valid and Y determines Z is valid, so we can say that X determines Z is also valid. This is through the rule of transitivity. So next, second set of rules are additional rules or secondary rules. In this, union, composition, decomposition, and pseudo transitivity. So first one is union. If X determines Y holds and X determines Z holds, then left hand side will be combined union of left hand side, that is X determines Y, Z holds. This is also valid. This is through the rule of union. Second is composition. In composition, if X determines Y and Z determines W holds, then XZ determines YZ holds. Both left hand side will combine and right hand side will also combine. XZ determines YW holds. Now third one is decomposition. If X determines YZ holds, then X determines Y and X determines Z also hold. This is decomposition. We can decompose the right hand side. For example, X determines YZ. We can decompose this right hand side only. X determines Y and X determines Z because both are the dependent attribute and they are dependent on X. So this is valid. Such case that XY determines Z, we cannot, we can't write X determines Z and Y determines Z. This is not valid. This is invalid. So decomposition says X determines Y and X determines Z holds. Now fourth one is pseudo transitivity. If X determines Y holds and YW determines Z holds, then we can say that XW, XW determines Z holds. So these are the references that have been used for this video. Thanks for watching this video.